Now, dear student, now today's topic is, I'll continue with the derivative, and today's topic is derivative of functions with respect to functions. Now, this is similar to the parametric equations. Last video we did related to the parametric equations. Now, say example, y with respect to x or v with respect to u. You'll get this kind of functions. Now, say differentiate sin x with respect to cos x, sin x with respect to cos x. So that. Now say this kind of questions that you will get. Y with respect to x means definitely we'll write dy upon dx. V with respect to u means dv upon du. Then sin x with respect to cos x means d of sin x over d of cos x. But we'll not do this particular problem by this method. That means you have to differentiate, you have to consider this functions u or v, this functions u. Let us suppose this one is u, this is v. If I consider, let u is equals to sin x and v is equals to cos x. Now, if I consider this one is u, this is v, then what we'll get? Actually, u, differentiate u with respect to v. That means in case of this kind of problem, what you have to calculate, u with respect to v means v with respect to u is dv over du. U with respect to v means du by dv. One functions that you have to consider u, another function you can consider v. Then derivative, it's like a parametric equation. Now next we'll solve numericals. Now say differentiate sin x cube with respect to x cube. Whatever the derivative we did till today, it is with respect to x. But now from today onwards, only for today's video, we'll differentiate these functions with respect to sin x cube with respect to x cube. And this is sin x cube is variable, x cube itself is a variable. Variable with respect to variable. For such kind of questions, what you have to do? Let first variable equals to u, sin x cube, and second variable is equals to v is equals to x cube. Then differentiate both the equations with respect to x. Differentiating with respect to x. Now what we'll get? U with respect to x is du over dx. And now then the derivative of sin x cube. First we'll differentiate sin. Derivative sin is cos x cubed into derivative of x cube will be 3x square. Now the du over dx equals to 3x square cos x cubed. Next we'll differentiate this v functions. V is equals to v with respect to x means we'll get dv over dx. Derivative of x cube is, it's very easy, 3x square. Now what you have to calculate, if it is u and this is v means u with respect to v means you have to calculate du over dv. It's like a parametric equation. To calculate du over dv, you just write du by dx divided by dv upon dx, so that dx get cancelled. Actually you will get du upon dv. Now what is the value of du upon dx? It is 3x square cos x cubed over, what is the value of dv over dx? It is 3x square. These two quantities get cancelled. Now the answer is cos x cubed. Now the next question is sec x with respect to tan x. The same way I'll do. Let u is equals to sec x and v is equals to tan x. Then differentiate both the equations with respect to x. U with respect to x, du over dx. And the derivative of sec x is sec x tan x. Now this is the value of du over dx. Now similarly, v with respect to x will write dv over dx, and derivative tan x is sec square x. Now next we'll calculate du over dv, that means u with respect to v. Du over dx divided by dv over dx. Du upon dx is sec x tan x over, and dv upon dx is sec square x. This and this get cancelled. Now then, you can simplify if it is a trigonometric function. Tan means we can write sin x over cos x, and sec x is 1 over cos. This and this get cancelled. Now we have, it is sin x. Now inverse trigonometric form. Now sin inverse 2x over 1 plus x square with respect to tan inverse 2x over 1 minus x square. The method is same. Let u is equals to sin inverse 2x over 1 plus x square, and v is equals to tan inverse 2x over 1 minus x square. Now I did this property several times in inverse trigonometry, or in derivatives also I did these things. Now this is a formula, it's a direct formula. Sin inverse 2x over 1 plus x square means we can write directly like 2 tan inverse x, and v is equals to tan inverse 2x minus 1 minus x square is also 2 tan inverse x. Now say both the values of u and v are same over here, so for this kind of function no need to differentiate both the equation. You just write, comparing these two equations, can I write u is equals to v, but actually what we have to find, du upon dv. So I'll differentiate this function, differentiating with respect to v. Differentiating with respect to v means du upon dv, du upon dv is equals to v with respect to v is 1. This is one method. You can compare these two equations. I'll do another method also. This is one method, easy one. Now next method is the same method I'll apply, differentiating both the equations with respect to x. U with respect to x is du upon dx. Another method, 2. Derivative tan inverse x is 1 by 1 plus x square, or it is 2 over 1 plus x square. dv upon dx is equals to 2 into derivative of tan inverse x. The same formula, 1 over 1 plus x square. It is 2 by 1 plus x square. Now after getting these things, what we have to calculate, du upon dv. Du upon dv is given by du upon dx divided by dv upon dx. Now then substitute, du upon dx is 2 over 1 plus x square. dv upon dx is also 2 upon 1 plus x square. This and this get cancelled, 2 to get cancelled, the answer will be 1. The same answer, this little lengthy one. This is another method. Now this is another important question, 4 marks type. Now x to the power sin inverse x with respect to sin 1. This is variable to the power variable. Variable to the power variable means, last video we did variable to the power variable, u to the power v form. I'll consider, let u is equals to x to the power sin inverse x, and v is equals to sin inverse x. I'll differentiate this one. Differentiating with respect to x, what will get? Du upon dx is equals to dy dx of x to the power sin inverse x. Now it is in terms of u to the power v. How to differentiate u to the power v? U to the power v dy dx of v into log v. We did these things in previous video, that you have to follow the another video also, the previous one. U into v formula, u dy dx of v plus v dy dx of u. derivative log x is 1 over x plus log x. Derivative sine inverse x is log x. Then derivative sine inverse x is 1 by under root 1 minus x. So directly we can write 1 minus x square. Now then I'll take LCM over here. du upon dx is equals to LCM within a square bracket. The LCM is x under root 1 minus x square is the LCM. After taking LCM, now we can write under root 1 minus x square sine inverse x plus x log x. Repetitions. Click. Continue this one. Now again you have to differentiate this quantity also. Since we have v is equals to sine inverse x, again I'll differentiate this one with respect to x. dv upon dx is equals to derivative sine inverse 1 by under root 1 minus x square. Now first copy this thing, so you can take a screenshot of this. After getting du over dx and dv upon dx, the process that I'll do over here. Now next, what we have to calculate? du by dx. du by dx is given by du over dv. du by dx divided by dv upon dx. du by dx is x to the power sine inverse of x within bracket under root 1 minus x square into sine inverse of x plus x log x over x under root 1 minus x square divided by dv upon dx is this one 1 over under root 1 minus x square, so that this and this get cancelled. The final answer will be x to the power sine inverse of x within bracket under root 1 minus of x square sine inverse of x plus x log x divided by, nothing is there, this one will be the required answer. Oh, x is there, x required. Now actually the concept of first order derivative is over, but still the next video will be a little lengthy one. Definitely I'll do some miscellaneous questions of derivatives next video, and that will be the last video of derivative.